Estuaries and harbors are some of the most physically impacted marine environments from anthropogenic sources. Harbors connect humans to the sea and have long been a place of high commercial and recreational development. They also are essential marine habitats and offer a home to very diverse marine ecosystems. As human populations grow and these marine habitats continue to be infringed upon, it will be essential to understand our impacts in order to mitigate our effects and manage vital populations. In our proposed study, we aim to look at how the change in behavior due to human activity affects the nutritional health of Phoca vitulina richardii, the northern Pacific harbor seal. We intend to conduct our research at Yaquina Bay in Newport, Oregon, and Neptune State Research Reserve. Newport is a highly impacted bay where Neptune Research Reserve is limited to inhuman exposure. There has been research done on how the foraging behavior of these seals has been affected by anthropogenic disturbances. From a case study done on harbor seal foraging behavior in San Francisco Bay, they concluded that due to impacts in their foraging habitat, the seals must move to deeper waters that are less impacted and execute deeper dives in order to obtain their food source. This dramatically affects how much energy a seal must expend to obtain their food. In a study done on their diving behavior, it was found that they prefer to dive at intermediate depths of 5 to 100 meters. The behavior of the harbor seal has been well researched, but how these varied behaviors affect their health remains uncertain. By changing the diet and energy expenditure of these seals, these impacts could be dramatically affecting their metabolism mechanisms and hurting their overall health. We aim to measure the fineness ratio to gauge blubber thickness of the seals in order to understand how these human impacts impact the seal's health. It has been found that seal blubber is thickest in the winter and is crucial for keeping them warm and nutritional stores. We hypothesize that we will find lower fineness levels in seals that live in higher proximity to anthropogenic activity.
So for this experiment, we're going to take 50 harbor seals from two different sites, Yaquina Bay and the Neptune State Park Research Reserve. And over the course of 3 years, we're going to tag these 50 seals and we're going to give them health checkups. And so the checkups will involve doing things like checking up on their teeth and their eyes, their ears, and we're also going to be taking measurements of their girth and their length. And we need the girth and the length because we want to measure their fineness, and we're defining the fineness as the girth divided by the length, and we're also going to say here that the higher the fineness of the seal, the higher their blubber thickness is. So if you've got a seal that is rounder in shape, it's got more blubber and therefore has better nutrition overall. So over the course of these 3 years, we're going to do an initial checkup where we tranquilize the seal, we attach the tags to it, we do the initial checkup, and then for 3 years after that, or 3 more times after that, we're going to kind of do the same thing minus the tagging part of it, and we're just going to keep an eye on the seal's general health.
Due to the different foraging habitats and habits, we expect to see different average fineness levels between the two populations of northern Pacific harbor seals. Those found in the Yaquina Bay study area are going to be found to have poor nutritional health, which is indicated by the fineness, and this is because they have access to 2 anthropogenic sites. In comparison to individuals found at Site 2, the Neptune State Park Research Reserve are going to be found to have better nutritional health, and this is measured by having a higher fineness, and those with higher fineness are going to have higher blubber thickness.
So for the significance of our study, harbor seals rely on fish for their sustenance, and they affect the rest of the ecology and the estuaries they inhabit. Because of these ecological connections, our study could have significant effects on the future scientific knowledge and improvement of estuary ecology. We predict that their health is negatively impacted by human activities with a decreasing fineness ratio as human proximity increases. Our study fills a gap in the limited research done on seal foraging and health, so studying seal health and effects on foraging and then adapting human activities due to our findings is a good option to improving both seal and estuary health. Negative effects on harbor seals are likely to have a cascade of negative effects on the rest of the organisms in the estuary food web. Our study would better determine which negative effects are the most significant and allow humans to take more specific actions to remedy them.